Scheisse, you phone. Do what I want you to do, not what you want to do. Okay, there we go. Okay, so what we know so far is this. If f of x equals x to the n, what's f prime of x? Yeah, the n comes down, the power goes down by 1. We actually proved this. We used the binomial theorem. We didn't write it all out because we didn't need to. All I needed from the limit definition of derivative was what's left alive, and then let h go to 0. So I used binomial theorem. Thankfully, we didn't have to go too far with it, because once I start getting more than 1h in a term, it's eventually going to go to 0, so who cares about it? Poor over 2. Okay, how we all doing? So that's the 2 levels of this. You've got to memorize these rules, but you also need to remind yourself this comes from the process. This comes from algebra. This is algebra. y2 minus y1 over x2 minus x1. That's where this came from. It's not some mystical, magical bullshit. What's the limit definition of derivative? What is officially, using the limit definition, what is f prime of x? Oh shit.
F of x plus.
Almost, you're missing something at the very beginning.
X plus h.
No, the f prime.
It's the what definition of derivative? It's the limit definition. So the limit, I know you know it back here, as h goes to 0. Go ahead.
F of x.
Oh, okay. F of x plus h.
Minus f of x over h.
Yeah. y2 minus y1 over x2 minus x1. That's why the x is canceling and have an h on the bottom. That is just y2. That's just rise over run. That's all that shit is. Okay. So on one level, I mean, calculus is obviously a higher level of mathematics. It is. Because the idea of limit is a little tricky. It's new. But what I'm trying to tell you is everything we're building is primarily built on the back of something you guys know crazy good. You guys know slope. You guys know algebra. You know slope. Okay. Can somebody tell me then, just to kind of play with this a little bit, for no reason whatsoever, this isn't going to come up in a bit. Sorry. What's g prime of x?
The limit is g approaches
The limit is,
G
no,
approaches-
no,
to 0.
h goes to 0. Instead of f, I'm going to put,
G
there we go.
x plus h minus gx over.
And this is why we normally don't use h of x for limit definitions, because then it gets really weird with the other h's, yes? Okay, are you guys kind of with me? So if I saw this anywhere in the universe, if I saw all this shit, I could replace it with this, yes? If I saw this anywhere in the universe, it just pops up some point today, I can replace it with this. Okay. So let's do this real quick. A couple of concrete applications of what we know so far, because we know more than just the power rule. What else do we know? What is the derivative of this?
Sine. Negative.
Negative sign.
One.
Yeah, how do I take the derivative of this?
1/5 times
Multiply.
I see you back there. Yeah. The 1/5 comes down, and then the power goes down by 1. What's 1 minus 5?
4. Negative.
Done. Yes, yes, yes. Each part, each term in a function. Terms are separated by pluses and minuses. I can just treat each one of them as its own little derivative problem. Cosine x, you just gotta memorize that that's negative sine x. That's another example of cosine being an asshole. Because cosine's got a negative on it when you take a derivative. And then the other one is just power rule. Yes? Yes? Are you guys with me? Yes. Okay. So you guys look bad at the math. Math exists because we want it to.
Is the derivative of sine x? You said it was derivative of cosine x.
Yep, totally. Derivative of sine x. So what about this here? What would I do first? No. What would I do before I even take a derivative?
Should discard it to power.
Yes. What's the cube root of x rewritten as?
X 1/3.
Now I take a derivative. People start putting just prime. Don't do a prime and then have part of it done and the other part of it you just rewrote, because then you're lying to yourself and you're going to make mistakes. You with me? So if there's any rewriting or simplification, do all of that first and then take a derivative. Then write your prime. So what's the derivative of 7 sine x? 7 cosine x. Beautiful. How's this work?
1/3.
1/3 comes down.
X.
1 minus 3.
Negative 2/3.
Done. Whee! Yes.
So what would the derivative of negative sine x?
All right. What's the derivative of sine x?
Cosine.
Cosine x. What's the derivative of 7 sine x?
7 cosine.
7 cosine x. So what's the derivative of negative sine x? Negative cosine x. The negative is just a coefficient. It's a negative 1 coefficient. Comes from the right. What's the derivative of negative cosine x?
Positive sign.
Positive sine x. Because it'd be negative cosine. Any coefficient that is there at the beginning comes for the right. It just comes for the right. Yeah.
Would you get negative 4/5 on the top one?
I don't know. So what happens in the power rule? You're cool with the 2/5? Because the power comes down, but then the power goes down by 1. So I got to subtract 1 from this, yes? Doesn't 1 just become anything over what I need? Don't I do 1 minus 5? So the shortcut is just do the top minus the bottom, put it back on the bottom, because that's a pattern we notice. That's what we would do. So we just do it. Where are you going? Oh, it's me. How you guys feeling? You guys all right? Sort of? Okay. Now, do you guys realize that there are so many functions we cannot take the derivative of yet? All right, so I really want to make this clear. Does anyone believe they can take the derivative of this function? Now, if you've taken calculus before, I don't want to hear it. I mean, based on what we've talked about so far in this class. Yes? I can't take this guy as derivative. I cannot. We can't do this derivative yet. Do we know what the derivative of cube root of x is?
Yeah.
Yes. Why? Why do I know what the derivative of the cube root of x? Why do I know it? Because cube root of x is x to the 1/3. Is that in the form x to the n?
Yeah.
Okay. What is this? Rewrite it.
Sine x to the 1/3.
Do I have a rule for sine x base to a number power? Do I have a rule for that? I don't have a rule for this. Yes? Do you guys see how we are going to start developing rules? Rules that will help us. If I have, this is going to sound just like that thing we did last time, that worksheet. Isn't there an inside function? Isn't there an outside function? When the inside function is just x, that's an easy problem if I know the rule. So I know the rule for something to the 1/3 power, don't I? When the inside power, that's still something to the 1/3, isn't it? But the inside, is it just x? Is the inside just x? Here. No, sine of x. I don't have a rule for that. Okay, so when the inside function is more than just x, oh shit. Maybe. Well, it's going to be more complicated. We don't know how to do it yet. Are you guys at all with me? Let me see. Do you guys know gears? I should have brought I got a spirograph game in my office, and I should have brought it. But you guys know gears? Yes. You ever ridden a bike and you change the gears and so forth? So if you have one gear on the inside rotating and another gear on the outside that is clicking along that's also rotating, isn't the speed of the inner gear based on its own rotation and the rotation of the outer gear? If I have an inside thing that's changing and an outside thing that's changing, then the whole amount of change depends on both of those. How much is, let me see, what's the derivative of x? Holy shit. So when I have when the inside is just x, it's not really contributing anything. It's just changing one at a time. Just say every step it changes by one. Okay, I think I'm going to stop right there because we will get to how to do this problem. I just want you to recognize that right now we cannot really differentiate a lot.
The function still do the same thing as the power rating says that you make it into like 1/3.
We'll get there. Don't try to guess. Okay, because it's not necessarily the most straightforward thing in the world. What about this function here? Is that in the form of something that we know the derivative of? Do we know the derivative of sine?
Yeah.
All day long. Do we know the derivative of x?
Yes.
Oh, hell yeah, we just did it, Jeff. Do we have a rule for polynomial times trig? We haven't developed a rule for that, have we? You guys got with me? So if I have just a function sitting by itself, the inside is just x, it's going to be relatively easy. If I have a product of two functions, if I have a function that's more than just x inside of another function, those are going to be more complicated. Maybe. Okay. So let's do this. Let's talk about a function like this first. That's the most basic one of these next rules we're going to talk about. So here's the amazing thing. Math people, the creative geniuses, we said, this is a rule about a product. Let's call it product. Well, that's actually good. That's not bad. It's called the product rule. I use it when I have a product of two functions. And just to kind of show you, here, let's do this. If we just thought that this derivative should be the derivative of x times the derivative of sine, number one, that's wrong. But number two, it's not easy. Yes, go ahead.
What section is this?
I don't know. 3-2. Sorry. I don't know. I'm sorry. If you ask me, I will think about it and remember, but I just know stuff. I don't know where the hell it is. Real quick, I really want you with me on this. Can you see how maybe a lot of you guys would go, well, that's how it should work, Jeff? Right? Derivative of x is 1, derivative of sine is cosine. Why isn't that right? Well, let me show you an example where you can see that it isn't right. You can tell. I have no idea why that's wrong. Now, I do, but there's nothing about it that goes, hey, I'm wrong. Are you good? What's up? Okay. Watch this. Let's do a function we know. What is the derivative of x squared? Don't overthink it. And again, just to kind of start formalizing this, the inside function is x, and the outside function is squared. That should work beautifully. The inside is just x. There's no freakiness going on. So the derivative is 2x. Can't I rewrite x squared like this?
Yeah.
Is that true? What if I then erroneously thought I could just take the derivative of each? What's the derivative of x? What's the derivative of x? Which one of these do we know to be right? This one. So is there an obvious problem then with this approach? All right, that lends more credence to that being wrong because this person just took the product of the two derivatives. We can see, at least in this case, it's not true. And if it's not true in this easy case, it's almost definitely not true in a more complicated case. I need you guys with me. I need you to see why we need these rules. Yes? And then we'll talk about what the rules are. Okay. Can you guys see the motivation here? The why we need a rule? Because I can't just assume to do each piece because it leads to something I know to be wrong. Okay. So how the shit do we do this then, Jeff? Well, let me write every single product of every function in the universe. There we go. You all agree with me that that is every possible? If f of x is x and g of x is sine x sine x is the one I had on the previous page, yes? This represents every single product of every function everywhere in the universe, yes? So if I can figure out how this works, I know how they all work. You guys at all?
Yeah.
So it's similar to the same thing as the fx plus h, and I can find the slope of all curves. This would be the same thing. Like this will make me find.
Yeah, if my function is composed of the product of two separate functions,
Then you can use the same formula for all different.
yes, I can use the formula for everything. I could even use the formula. One of the first things we're going to do, I'm going to use the formula we create. I'm going to use it on x times x and show you that we do get the right answer then if we use the right method. Earlier, we didn't get the right answer, yes, did we? Drink, Jeff. I love you guys so much. So just keep in mind, we tried to apply an incorrect idea. We thought, dear God, please, let me just take the derivative of each piece, Jeff. And we did one, went, well, that's not right. Shit. So we had to take a step back. And we're like, okay, Jeff, maybe we do have to go to like proving shit. This is always more difficult. Because how many functions did I just write? Infinite many. You understand? I just wrote an infinite number of functions up here, did I not? Because how many things could this be? Infinite. I mean, infinite. So it's infinite times infinite. It's infinity squared. Okay. Which is still just infinity. Yes?
Sorry, so if you put x squared, you can use the power rule to figure out the derivative of x squared, right?
Totally.
But then you could also use the product rule.
Totally.
When you
Anything that could be written as a product, you could use this rule.
So
And it's got to come out the same as some other rule that would apply. Or else the whole thing is shit. And we can all go. Whenever I say that, somebody out there is like, please make a mistake, Jeff. So it's like, it's all shit, let's go.
So I'm sure you can get this, but when do you differentiate when to use the power rule and when to use the product rule?
Oh.
You could use.
I use the product rule when my function given isn't just a straight x squared. Like, I could rewrite that as x times x and use the product rule, but why would I? Because I have an immediate rule for x squared. So I only use the product rule when I can't, like, rewrite what I'm given into a simpler form.
So
Okay. Like x times sine x. I can't do shit with that. I would need product rule to help me. Okay. I love you guys. How do I find, what's the only method we have at the moment to find this guy's derivative?
Find the derivative of
No.
Like P prime on
All right, I'm sorry. I don't blame you. Some of your brains don't want to accept this. We're going to use the limit definition of derivative. It's the only thing we know. Is anybody excited? I am. Everybody just stay with me. If you don't want to write all this shit down, it's okay. I'm not going to cry. You've got the video here. But you should write this down. Just to remind yourself in the future, oh shit, this came from a valid way. This came from algebra. Again, we're going to do algebra right now. And we all believe in algebra. If you don't, well, at least you're here. Help me out. Just to remind you guys, just look at this for the moment. How would I figure out P prime? Limit as h goes to 0 of what?
F of
P?
P of x plus h minus
P of x.
Why do I call it P, though? Because I'm such a creative guy. P for product. Okay. You guys with me? We did this earlier. If it was G, we'd put G of x plus, if it was A, if it was W, we'd put W of x plus H, blah, 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 blah. Okay. Wasn't sure what to say. What is P of x plus H? What is it? What's P of x plus H? You can do it. What's P of x? What's P of x? F of x, G of x. That's what I'm going to put here, yes? What's P of x plus H? Don't overthink it. What's P of 7? What's P of 7? F of 7 times G of 7. What's P of x plus H?
F of x plus h times g of x plus h.
Kick ass. Now listen. This is a perfect spot for you guys to realize so many things in mathematics is easier than it seems. Does that look nice? Does that look nice? No. Was it hard? Was it actually hard to figure out what P of x plus H was? No. Functions work the same way always. You just plug whatever's inside, you plug it inside. Yes? Now, it's what we do with it after that that gets a little freaky, but that stuff right there is easy as shit. Functions, notation, when you plug that stuff in, always easy as shit. The next step is going to be more complicated, but that step is easy. What do I put here? F of x, g of x. Now, right now, I would completely agree with you if you're like, that's so much worse, Jeff. What have you done? But this is all we have. This is the only tool we have right now to figure out what the derivative of something is. All right. Do you see elements of something that looks familiar?
Yeah.
Do you see f of x plus h minus f of x over h, sort of? Sort of, yes? Do you guys see that in there? Do you guys see those pieces in there? Do you see a g of x plus h minus g of x over h in there? Do you see that kind of in the mix? Now, obviously, that's not in there. Because what I have is this times this. Not just one of them alone, yes? But here's the trick. Okay, I really want to prep this correctly. I'm about to do something that there is no way you would think of it. Now, let me be careful. There's always a chance that you could think of doing this, but it's just so out of left field. But the minute you see it, you're going to start to see it happen more and more often. It's such a cool idea. We've actually done this before. Off the top of my head, I can't remember. Yes, we have done this before. Do you guys remember how to complete the square? Don't you take half the middle, do square it, and then you add that and you subtract it? Yes? So if I add something and subtract it, overall, did I change what I had? No, of course not. Way to go. We just made it look different, correct? And that made it doable. I don't know if you guys are with me. If you completely forgot complete a square, write that down somewhere, review it. It's going to come up again later this semester. Stay with me. So what I'm about to do is freaky and I love it. I'm going to do this. I'm going to make a lot of room. I'm going to subtract something. And I'm going to add the same thing. So this and this are new to the equation, yes? To the expression. Are you guys with me? Did I actually just change the expression though that I'm working with?
No.
I didn't change it worth shit. If somebody's like, I'll give you $20, and you're like, add 10 and subtract 10 from that, and then we got a deal, you know? The guy's like, okay, I'm gonna give you $20. You didn't change anything about what I had. I guess at all with me. Just on that. I could have put anything. I could have put minus W plus W. I could have put minus hot dog plus hot dog. Yes? I could have put minus Jeff plus Jeff. Yeah. But only this helps. And some of you guys are like, how does that help, Jeff? Now it's just not more of the shit that made it bad in the first place. Good job. But notice what I could do. I could do this. I could break it up into two expressions. We do this step by step. That's probably a good idea. Do I have enough room? I'm going to try to write compactly. So that's this piece, yes? Yes? And I'm going to write this piece over here. Do you guys see anything I can do with the top here? No, definitely not. There's nothing that would cancel.
Factor out.
There's no like terms. Yes, what can I factor out?
G of x.
G of x plus h. I'm going to do this. So I'm going to put a g of x plus h over here. I'm going to factor a g of x plus h out. And what am I left with? F of x plus h, that's gone. Minus f of x, that's gone. Do you guys see what that just happened? Just to make this a little better, I put that over once. Yes? Do you guys see what I did? If I see a g of x plus h in both terms, can't I take the dumb thing out? Now, I did something weird. I didn't put it in front. I put it in the end. And who gives a shit? 6 times 8 equals 8 times 6. I can put it either way I want to. Yes? Okay. What can I do over here?
Yeah.
Take out an f of x. Yes? That's what's the same. There's an f of x here. There's an f of x there. There's not a g of x in both, is there? There's a g of x plus h and there's a g of x, yes? So if I take an f of x out, what am I left with?
G of x plus h and g of x.
Now, what did we say earlier today? Almost like I planned it. Almost like I planned it. What is this shit? What is this? You know, we know this. What is this? Come on, you know this. What is this?
Definition.
Sure, so what is it? What can I replace it with?
F of
F prime. Right? Let me not, Jeff. And this is still the limit here. And what's the limit as h goes to 0 of this? F prime. What's the limit as h goes to 0 of this? What happens when h goes to 0 here? What do you get?
G of x.
G of x. That's f of x, yes? And then what's this?
H.
Do it again? No, come on, you can do it. We wrote this earlier. Yes? That's G prime. Do you guys see that? That's G prime. So the derivative of the product is the derivative of the first times the second plus the first one times the derivative of the second. Notice how fundamentally what this rule says is if I have a product of two functions, they each get their own term. Here we go, you ready? This is the first of 3 rules we're going to learn. Sounds very Christmas Carol, right?
The first goes.
Every single damn rule breaks down to each piece gets its own term. It's kind of dumb. It's kind of awesome. I'm not saying they're all going to be the same rule, but they're going to have that behind each one of them. Behind each of them is every part in your problem gets its own term. So we're going to stop there. All right, let's see this thing in action. So let me just write this result down for us again. So let's go back to that problem we had earlier.
Is that the product formula?
That's the product rule, yes. I got a little handout I'm going to give you in a minute that's got a lot of practice problems on it, and it's going to list the product rule and another one of the rules. We'll do that before we talk about the third rule. Third rule is everybody's favorite. So let's go back to this one I had written earlier, and then we'll do x squared again. Let's look at this one. Can you guys identify that as a product? Do I have two functions that are multiplied?
Yeah.
Yes. Therefore, I want to deploy the product rule. It's kind of silly. So what you have to look for is this is a function where the parts of it, each part of it, I have a rule for. I know what the derivative of x is. I know what the derivative of sine x is. But they're connected with a multiplier. They are a product of two functions. Oh shit! I have to use the product rule. And here's what I try to get students who are first learning calculus. I want them to do this. This will help you. Don't try to do the derivatives as you're writing the rule when you're first starting out. So here's what I mean. What's the rule say? Take the derivative of the first piece, yes? Take the derivative of the first piece times the second plus the first piece times the derivative of the second. So what I'm doing is I'm doing two things. What's the nice word for that? Yeah. I'm making the cognitive load lighter for myself. I don't have to do too many things at once. I'm applying the rule by itself, and then I'm going to take the derivatives. I'm also memorizing the rule better. If I apply just the rule by itself, I'm memorizing the rule, and then I'm doing the separate thing. So what is the derivative of x? That's what this needs, yes? 1. So we got 1 times sine. And what's the derivative of sine?
Cosine.
Say again?
Cosine.
Cosine. than we wish it was, but too damn bad. That is what it is. And it should make sense. If I change x, you ready for this really silly statement? If I change x, is x changing?
Yeah.
Is sine x also changing?
Yeah.
Are they changing at different rates? Yes. Don't they have different slopes? Is the slope of sine x the same as the slope of x? No. So you have the product of two functions and you're trying to figure out the whole thing. How's the whole thing changing? It should be a little more complicated. I've got each part is changing itself. And then the whole thing is changing because of those two things. So it's sort of like this is the contribution from this guy and this is the contribution from the other guy. Maybe. Okay. So let's do like I promised. If I rewrite x squared as x times x, what do we get when we apply the product rule? How do I write the product rule? It would be x prime times x plus x times x prime. Yes? What's x prime? 1 times x is x. What's x prime? 1. So x times 1 is x. What's x plus x? Is that the correct answer? What's the derivative of x squared? Thank you. So is that the right answer? Yes. You guys see, if I use the right tool, I will get the right answer. When we first did x times x, we used the wrong rule. We used a rule that doesn't exist. We just hoped it did.
Oh.
But even if I read, now listen, this goes back to your question. Would you ever frickin' use product rule to do x squared's derivative?
No.
Shit, no. So why did I do it? Because I want you to buy into this rule more. We did something we knew already a different way, and we got the same dumb answer. So when does product rule work? Anytime you can rewrite your thing in terms of the product of two functions. You guys kind of with me? When do you have to use it if that's the only way it could be written as the product of two functions? Yes? So if I said take the derivative, here's a problem I love to give. Might as well give it to you now and see who remembers. What's the derivative of x times the cube root of x times the square root of x?
Should be x times x over 3 times x.
Okay. So you're saying radicals suck, like you said, Jeff. You can disagree with me, because everybody's got the right to be wrong. Now, I rewrote it. I didn't put a prime, because I haven't done a derivative yet. Now, could you use the product rule? Yes. Because the funny thing about the product rule, if the product is f times g times h, it's f prime gh plus f g prime h plus f gh prime. It just extends for how many functions you've got multiple. So do I want to do the product rule for each piece so I have 3 terms? I don't want to do that shit. Why do I not need to?
Because you use the power.
Can I rewrite that as not a product anymore? Of course. How do I put these together? Yes. 1 plus 1/3 plus 1/2. 11/6. Beautiful. So what's the derivative? 11/6 x to the 5/6. Would product rule work? Hell yeah. Do you want to use? No. So I think I've said this already once. I'm going to say this throughout the whole semester. Before you attack something with calculus, try to simplify. Yes? If you can simplify what you're given, you're making the calculus you have to do simpler. Does that make sense? Maybe. Let me stop for a minute. How you guys feeling? Some guys look. Yes. Oh. Real quick. 1/3 plus 1/2 is 2/6 plus 3/6 is 5/6. Plus 1, 5/6 plus 1 is 5/6 plus 6/6 is 11/6. So all we did was we added powers, because that's what we do when we multiply like bases. And then we got LCD and put them together. Yeah. 2. Maybe. Yes.
You said 1/3 plus 1/2.
1/3 plus 1/2 is 2/6 plus 3/6 is 5/6. Plus 1 is 5/6 plus 6/6 is 11/6. Cool. We created fractions. They do what we want. We don't let them bother us. Some of you guys can say that all you want to, Jeff. They're gonna fuck. Okay. Is everybody semi-decent with this? A little bit? Okay.
Just more examples.
Sure. Oh yeah, I gotta look that up. I'm not sure where that happens. Kind of running out of. I'll just go back to F. What else can I put down here? Yeah, let's do this. Now you could distribute, and why would you? Yes. How many functions do I currently have that are multiplying? 2. Beautiful. If I distribute, now I have several groups of one. Don't do that. No reason to. Doesn't do anything for you. Do I have the product of 2 functions? Yes. What can I use then? That's insane. So product rule would say, get rid of the first, leave the second alone, plus leave the first alone, derivative of the second. So that's basically saying each piece gets its own term. Yes? And then you focus. None of this shit matters on the next step except him. That's my whole universe is this guy. If you need to, just physically cover the rest of that shit with a piece of paper. Because sometimes your brain just sees all of it and goes, no. What's the derivative of 4x squared? That's my very next thing I'm caring about. 8x. What's the derivative of negative 7x?
-7.
What's the derivative of 1?
0.
Good.
Why don't you just use the power?
Sorry?
Couldn't you just use the power rule instead?
What do you mean? Sorry. Yeah, that's what we did. We used power rule.
That's the point. Well, like.
No. You can't choose to do power rule on this because this is a product of 2 functions. Yeah. And what happens here? 1/3 comes to the right. What's the derivative of cosine? Negative. Yes. And then it kind of depends on what I would need you to do next, and what would you do next on this is nothing. This would be where we end. But you could take the negative out there. You could write this as, let's say 8x minus 7 over 3 cosine x minus, yes, 4x squared minus 7x plus 1 sine x over 3, but it doesn't really matter, right? Those are both equally valid. Yes?
So let's say that question was on the test, we would just say differentiate, and we'll just leave it as a first.
Yeah, you leave it as this line, or you could do this, right? Either one is fine. Neither one of those is better than the other one. Okay. Maybe. Normally, at the very least, I don't want you to have plus, make this a minus, yes? Okay. All right, let's go over the other rules and then have this little worksheet of stuff for you to try. Now, you're not going to believe it. Anybody have a guess as to what the next rule might be?
Quotient.
That's insane. So if we do a rule now for multiplying 2, let's do a rule for dividing 2. So what if I had a function, which I'm going to call Q, that looked like this? How would I figure out its derivative?
Divided by 1.
I don't want to know the rule. You're not supposed to know the rule yet. But if you read ahead or whatever, it's great. What do I use? What's the only thing we have at the moment?
Is a limit sum.
Limit definition, yes. You guys excited? Good. What's Q of x plus h? F of x plus h over.
G of x.
That's insane. So then Q prime would be the limit okay, that I'm gonna jinx it, but alright, that's still horrific writing, but for me that's like some of my best writing I've ever done. And that's saying a lot, the fact that it's still bad. I guess with me.
Yeah.
Now listen, do you notice right now there's a part of your brain that says, I don't want to do this. So that it's trying to make you feel like you don't know what to do. Yeah, you do. You know how to write this shit. You know what Q of x plus h is. You know what it is. You don't know, but you don't want to do it. I don't blame you. I want to because I'm weird. But there's a distinction between I don't want to do this stuff and I don't know how to do this. Yeah, you do. You know how to set this shit up. Now, does anyone have a suggestion? Now that we have set it up, that's how it has to be set up. That part's easy. What could I do?
Multiply by the contingent, I'm assuming?
Huh?
Multiply by the contingent?
Contingent?
The
The conjugate? No, there's no radicals, there's no bottom has more than one term in it. No, there's nothing to factor here, yes? Nobody's got like anything.
Make
Yeah.
the denominators the same.
Yes, there you go. Don't have fractions inside of a fraction.
Yeah.
Alright, so whenever I do that, I try to consolidate some of my stupid fractions, yes? Get them together into one place. Fractions suck, but they really suck when they're all over the damn place. You try to get them all in one place. Alright? So what's the LCD going to be? Don't overthink it. What does he need?
G of x plus h.
No, he doesn't. He already has one. What does he need?
G of nothing.
Yes, he does. He needs a G of x. Yes? He's got a G of x and he don't. What does he need?
G of x plus h.
G of x plus h. So they need each other because, that's exactly what they're missing is each other. Yes? Do they have the like denominator? Okay. Now, how do I? All right. Look, I'm gonna do this the long ass way, and then I'm hoping you guys pick up on something that's gonna save you a lot of time and grief. Okay. Just do it, Jeff. All right. So this would become f of x plus h times g of x over g of x plus h minus f of x, g of x plus h, all over h, yes? Since I have like denominators, I could put them together, right? This top minus that top. Yes, go ahead.
Can you cancel out?
Hell no. Hell no. Hell no. If I try to cancel out, it would be this divided by this minus this divided by this, and I go back to where I was. What would come out? Could I take an x plus h out? No, because there's not an x plus h anywhere in here. Ooh, this is going to freak you guys out. Nowhere in there is there an x plus h. I see an f of x plus h. And what is that? I don't know. I don't even know what f is. All right, let me stop for a minute. Because some of you guys, I'm almost certain. Some of you guys are sitting there again, thinking to yourself, something punking me right now. I can't do shit with this. Not what you want to do. But we're almost there. Believe it or not. Does the top look familiar to anybody? Just the top.
The product.
Yeah.
Except it's missing derivatives. So isn't there like a f of x plus h minus f of x over h in there? Doesn't this feel like the proof we just did earlier for product rule? Okay, we do a couple things. Do I still have a fraction inside of a fraction? Yes. Let me do this on the side real quick. This is an incredibly good shortcut to just know about. If I have 1 over x, how do I want to say this, Jeff? Let's say I have 7 over x minus 2y all over m. Yes? This is simply, what is 7 being divided by? X minus 2y and m. All right, so 7 is being divided by m and x minus 2y. You just put all the frickin' shit together that you're dividing. Yes? What's 1 divided by 2? A whole pie cut in half is a half a pie. And then you cut that in fourths, that's an eighth of a pie. 1/2 divided by 4 is 1/8. You just consolidate all the shit that's dividing this 4/7 in this case. I don't know if you guys are with me or not. This is a big thing from algebra that if you just realize this, and this is how often is this kind of thing going to happen to us? Often enough that you'll be happy you know this. So what's the quick way to rewrite this that I would not have written it as, but I just wanted to show you this? What am I dividing all this shit by?
H of X and
Both of these. So I can rewrite this. There, that all says the same thing. It's being divided by this business and this business. There. Yes, sir.
What do you have to put parentheses around it?
Around what?
Around the g of x and g of x.
No, it's all multiplied, so who cares? Right. Okay. I love you guys. So real quick, earlier we derived the product rule. Is the product rule difficult to apply? Just like a problem like this. Is that, did that take us long? Now, it should make sense though, that to get the product rule to exist, that looks more like this. In this case, we're doing the quotient rule, which of course is a little worse. When I bring division into things, it should be expected things are going to be a little worse. But the quotient rule feels like the product rule, and once we talk about the chain rule, I can go back and show you why. But let's keep going because we're not done yet. Let me write where we left off up here. What time is it? Oh, okay. Take a break in a little bit because proofs are just soul sucking. So just give me a second here. Okay. Oops. There we go. So, do you see how the top I can do exactly like I did before? I could, in this case, I'm going to subtract and add the same thing.
Complete the square?
Not complete the square because they don't have squares, but it's the only reason I brought complete square is because there we add something and subtract something. That's exactly what I'm about to do. Yes?
You can break it apart into two.
Not yet. I could, but it wouldn't get me anywhere. I wouldn't have f of x plus h minus f of x. If I just broke this over this minus this over this, that would do nothing for me. In fact, the g of x and the g of x plus h would just cancel again. Okay, so here's what I'm going to do. What I'm going to do, in fact, here, you guys help me out. I really want you to kind of get a feel for what this feels like to realize what you have to do. Do I have the part right now in what I've written so far? There's more to this, obviously, but I'm going to stop right there for a moment. Do I have the first piece of what I need for f prime? What's the first piece of f prime? Limit is h equals 0 of? What's the first piece for f prime of x? Limit is h equals to 0 of? F of x plus h. Do I have that? I do. I totally do. What else do I need? Minus f of x. Yes? And this dumb thing has that little freaking parasite on it. Yes? It's got a little G parasite just. I want to get rid of it. So what I'm going to do is this. This is why. I need there to be an f of x. Yes? But I also need to be able to get rid of this, which means I'm just going to give this guy that so that I could then factor him out. I love you guys. Over here, you see how that's already a minus, and do you see how that's a gx plus h? So I'm going to do two things. Let me see. Well, let me do this. Don't I need a, well, actually, let me just stop, because I need to add this no matter what. But do you see how this gives me what I need? Because am I going to be able to factor the f of x out? Am I going to be able to factor the f of x out? Do they both have f of x? So will I be able to factor the f of x out? Yes. And will I be left with g of x plus h and g of x? over h. Yes? Okay, just go with me for a second. I love you guys. I'm going to do something a little weird, and I'm going to undo what we did earlier, but I'm going to do it now, and you'll see why. I'm going to do this. I'm going to break that back up, but just the other way now. Okay. I love you guys so much. Do you now see that if I factor g out, don't I get the limit f of x plus h minus f of x over h? And then just f prime? Do you see now that you could, now that you've seen this is something you're allowed to do, you could do something similar to this. If you just stop and go, I need this, I need that to go, okay, I need this. You could figure out what to subtract and add in a different situation. How often does that happen in math, Jeff? A stupid amount. So many times. It's kind of dumb. And this is your first little baby's first step into this idea of you're allowed to subtract and add. The same thing. Anywhere in the universe you want to, just sometimes it's useful. Okay. I love you guys. Thanks for putting up with me. So now, out of these two, I can take a g of x out, and then I'm left with f of x plus h minus f of x all over h. Over here, what's wrong over here? Does anyone see what? I could take an f of x out, yes?
Yeah.
But then I'm left with g of x minus g of x plus h. Is that right? What should it be for g prime? What should be first? G of x plus h. So I'm going to take a negative. How do I want to write this? I don't know, Jeff. Yeah, let's just do it. I'm going to take a negative f of x out. And then I'll have g of x plus h minus g of x all over h. That's from this piece here. If I take a negative f of x out, that becomes positive, that becomes negative, over h, and this whole thing is over g of x plus h. This is so exciting. Yeah. All right, sorry guys, just to cut to the chase now, watch this. What's the limit as h goes to 0 of this? F prime. And there's a g of x here, yes? Minus, here's an f of x. What's this? The limit, that's g prime. And what happens when h goes to 0 down here? I get g of x times g of x is g of x times g of x, g squared. That is the quotient rule. Good Lord. A real quick thing. Which term am I taking the derivative of g? You guys see the term where I've got g prime? Is that term positive or negative? Why does that make sense? Where was g in the original problem? Where is g? It's on the bottom. Yes? Give me a second. If g's on the bottom, how can I rewrite it to a power? It would be to a negative 1 power, correct? If I take a derivative of something to the negative 1 power, won't the negative come down? Okay, so which thing is negative? The one when I take the derivative of the bottom, because the bottom would have a negative 1 exponent that would come down. So do you see how the top is basically product rule, except there's a minus and not a plus? Because of what I just said. And of course this guy's very different. There's a whole song for this dumb thing, which I hate. Because it actually kind of works both ways, and it never helped me out. Here's my song. You guys, anyone know the song? Hi, low man, blah, blah, barf, barf. Okay. Here's the song. Top first. The song is top first. That's it. Top first. What do I take the derivative of first? The top. Yes? That's all I really need to know to kind of put this thing together. If you like this song, I'm not saying you can't use it, because I'm not going to know what you're singing to yourself in your head. You could use it, which is just as crazy as Sokotoa bullshit. Okay.
Sorry, what's that next to the g times gx? What is that?
Where am I at?
The top?
That's a time symbol. I don't know why I decided. Huh?
Times the one to the
This is f prime of x, g of x, right? Minus f of x, g prime of x. I'm not sure which piece you're having trouble with.
that's an x?
Yes. So here, let me write this. If I have f over g, the derivative is f prime g minus f g prime over g squared. Is that better? Just focusing on what's important. Yes? Okay. So that is quotient rule. let's try one example, and then I'll ask you guys what you want to do. Got to use a Q. It's all right, Jeff. What about here?
Can you show the product rule?
Product rule?
That's
Yeah.
the quotient.
Oh, sorry. What do you want to put, Jeff? Sure, just this here. There we go. Now, quick question. Well, this is an interesting question for you guys. Could you simplify this? You could long divide or synthetically divide, right? Do you understand how that's not necessarily going to make this one easier? It's actually better to kind of keep it together. Do I have a quotient, a division of two functions? Yes. So I can use quotient rule. Yes. So what does the rule say? How does the rule work? What goes first? The derivative of what? The derivative of the top. Good. Times the bottom. Help me out. Minus
the top.
the top
Times the derivative of the bottom.
times the derivative of the bottom. All over
X plus 3 squared.
x plus 3 squared. So just apply the rule, then do derivatives. Now, do you have to do that? No. If you want to save time, you can try to do it all at once, but then you make silly mistakes, especially if you're first starting out with this. If you've done this before, then you can do whatever the shit worked for you. What is the derivative of x squared minus 4x?
2x minus 4.
Kick ass. What's the derivative of x plus 3?
1.
Good. Do you see how I am splitting up the things I have to do? So I'm not trying to do too much at once. If you want to be nice to yourself. If you don't, then do it all at once. And now I just distribute. I get 2x squared minus 4 plus 6 is plus 2 minus 12, and they distribute in negative. And then I can put my like terms. I almost don't care now. I'm getting bored. X squared plus 6x minus 12. Will that factor? No, not in any meaningful way. So that's q prime. Is that all right? I mean, so the first step is calculus, and then the last many steps is algebra, which is basically what most of calculus is. Do you also see how this is, again, since it's fundamentally product rule with a minus and with a g squared on the bottom, it's still everybody gets their own term. Everything involved in the original gets its own term to have a derivative. That's behind every single rule we're going to talk about today. So my question to you right now is, do you want to take a break right now, or do you want to start working on this worksheet and then take a break a little bit after that? Which one? Anybody feel? Take a break? All right, let's do it. So come back at 5 till.